Hey Josh, ever heard of Edison Motors? Hey guys, Josh with Dip channel, and today what we're going to be talking about is something I have gotten so many comments on, and that is, hey Josh, you should do a video on Edison Motors and their diesel electric truck. Most of these people don't know is I am one of the first people to have done a video on them, and I did it way back in September of 2022, which is a year and a half ago, but in the EV world, that's a long time ago. And yes, I do know who Edison Motors is, and like I said, I already did a video on them, but what I wasn't really aware was how many improvements they've made, how much they've grown as far as not only subscribers, they've well surpassed me in subscribers now, but they have, from Carl, their blue truck, made Topsy. And I knew they were making a new truck. I didn't realize, though, and after watching their videos, how improved and how awesome Topsy is. So what we're going to be doing is I'm going to be watching their video and kind of discussing about that truck. Not only that, their decision to go into the pickup truck market. Not making pickups, but I guess they're going more into the EV retrofit market, which that's a lot more of a niche market than the pickup truck market as a whole. So let's jump into it. And first, let's look at Topsy and talk about kind of what's going on with that truck. Okay, so here's how the video is going to get started here. And this is Topsy. He's going to say that, but this is their first production prototype. So this is kind of what they want to build, whereas the Carl, their older truck, was a truck that was already built that they retrofitted over. So I'll let Chase, he's actually the CEO of Edison Motors, talk about it here, and I'll just kind of stop and interject when I think I need to. So
welcome to Edison Motors. I want to show you our electric truck, show you how it works, show you how it runs, and really what makes an Edison truck an Edison truck. So to introduce us, this is our first production prototype. We named it Topsy after the elephant Thomas Edison electrocuted, but this is the Edison truck. Start with,
so I'm gonna stop him right there. So Topsy, I've actually heard, I didn't know his name was Topsy, or her name actually, but there was an elephant electrocuted in the early 1900s. Apparently it had killed a bystander. There was a whole bunch, there's a long story behind everything, but Edison, Thomas Edison, didn't actually have anything to do with electrocuting Topsy the elephant. He wasn't even there. If you want to look it up, there's a whole long story about it, but it was done at Luna Park, and the owners of the elephant basically, maybe they weren't the best characters, but they wanted to get rid of this elephant. It was a problem elephant, and no one would take her. So basically, what he was saying there is, yes, an elephant was electrocuted, but it actually wasn't done, or it had nothing to do with Thomas Edison. Now, that's not to say that Edison, in the early days of the electrical system, they call it the War of the Currents, they would electrocute animals to show you how dangerous DC or AC current was. But actually, Topsy, that wasn't one of them. But let's get back to the trucks, not about elephants here.
That is reinforced directly to the frame rails. It's hard to show, but these frame rails here run all the way out. There's no drop leaf. There's nothing that comes down as an extra piece. You have full.
So I'm going to stop him right there. So one thing that I noticed right here was that is a huge heavy-duty bumper, and that's actually part of the truck itself. And most large truck bumpers, or cow catchers if you want to call them, they pivot. So they're bolted on with kind of like door pins or hinges, and usually you unscrew them and then pull a big pin out and they flip forward. That's because the hoods on most trucks, obviously, flip forward. That's how you open the hood. This one, I was looking at it, I was like, this is going to be a nightmare because this has this large grill and bumper, but no way to pivot it forward or move it out of the way from what I can see. But it doesn't really matter because he's going to show you, this actually has the butterfly style side openings that you don't really see on trucks anymore. Maybe the older Fords and stuff had that, but it's very rare to see on a truck now where pretty much all the hoods are fiberglass and they pivot forward. So here we are with the hood open. Like I said, it's a butterfly style hood. Positives and minuses to that. Obviously, it's a little easier as a mechanic, usually to stand next to it. You can sit on it, work on it this way, depending on how accessible certain parts of the engine. This could be good or bad, depending on what you're doing. But as you see, it's actually very good access to the top of the engine here. And he's going to talk a little bit about the engine itself. Not only that, look at next to them, they have some, I believe one of those is the shop supervisor dog. So
Under the hood here, we have a Caterpillar C9 diesel generator. This literally does nothing but just recharge the batteries. Think about it as you're carrying around your onboard level 3 fast charger. Of course, in there, things are easy. I love the butterfly hood because you got a little workbench. You're sitting here, you got a little workbench to sit on, wrench on the truck, you can lay your tools down there. It's one of the reasons why I like a butterfly. Some mechanics hate it. Personally, I think it's nice to have a little seat as you're working. So in this truck, we do have a diesel generator.
So what he's saying there is, yeah, he's talking about the hood design, and it's a C9. Now, a lot of people keep saying it's a C or a 9.3, which is, this is not. This is actually the truck style C9. So there's a big difference between the truck style C9s before they went to the common rail. This is actually an engine that was designed and produced in 2004 to 2007. And this engine is what they call a Huey engine. This is not the later one, or the one, the C9.3, which they have now, which is a common rail. And those have EGR systems. Although CAT doesn't call it EGR, they call it NRS, which is NOx reduction strategy. It's the same thing as EGR basically though. This doesn't have any emissions on it. There's no IVAs, there's no EGR. This engine was not designed with a DPF or an ARD head. It's a very, very simple engine. It's basically a beefier version of the C7 as far as fuel system design goes. But one thing that's nice about a C9, it's a 9 liter opposed to a C7, which is a 7 liter. C9s have wet liners, so you can pull the cylinder head and rebuild it in chassis instead of machining the engine block.
Generator, but the nice thing about our driveline system is that it does not have to be a diesel. You could put a natural gas generator, a propane, a gasoline, you could put a hydrogen fuel cell, or you could just stack more batteries under the hood if you want full EV. Our inverters do not care where the power comes from. This is a totally fuel agnostic truck. We just went with diesel generators because diesel is what we know. It's a proven variable, and it allows us to test everything else without getting too fancy under the hood. Here we got the...
So that's a very good point there, and that's one misconception I'd actually heard was, oh, it's going to come with the C9, which obviously that's an older emission style engine. But what he was saying there is you don't have to get it with a C9. It could literally have pretty much any power plant as long as it's powerful enough to turn the generator in. Now that's very important because one of my biggest fears with this prototype or design is the emissions regulations. Obviously that engine, it doesn't take DEF, doesn't have a DPF, doesn't have really hardly any emissions. Now some people might say, well, it doesn't matter because it's actually an electric vehicle. Well, if you probably ask the EPA, they're going to say, open the hood, and the hood's going to have an old diesel engine, and they're going to say, that's a no-go. But let's say if you wanted to ship or produce this and go to somewhere like California. Well, you could run a natural gas engine, which basically doesn't really have the same very stringent emissions problems as their diesel engines do now. So you could run this truck other than that CAT engine in there. Now in Canada, I'm not really sure what the regulations are as far as emissions compliance goes, but it's very good to know that although I love CAT diesel engines, making them in a new production truck with the emission standards complications would be very difficult, but it sounds like they've already got that figured out.
Here we got the Edison cab. So we went with kind of a dozer style cab. It looks more like a skidder or a loader because it's meant to work off highway. It's meant to be a heavy vocational truck. So we really copied that bulldozer skidder design, and once you sit in it and drive it, fantastic. Also, we are the only electric truck with a drop visor because you need to have a good visor on a truck. Stop making electric trucks without visors. Bring the visors back. Okay, one of the things too is with our mirror style
One thing I want to mention is look how nice this truck looks. Compare that to the Tesla semi truck. I would say it is, yes, it's semi a truck. It's not really a truck. I'd say it looks like a box. Now, gotta give it to Tesla, it might be more aerodynamic, but their design doesn't really make sense in any sort of off-road or long-haul application, which is what most trucks are used for. It doesn't make sense to not have a way to charge the batteries on board. That's where Edison Motors comes in. They have a power plant on board, and it doesn't only have to be diesel. It could be, like they said, gas, hydrogen, whatever. But the Edison truck is, in my opinion, obviously, looks are subjective, but I would much rather have that Edison truck, just for appearance sake, than the Tesla truck. Now he's in the interior right now. He's going to show you the cab, which maybe some people don't find that as interesting. Remember, the operator or driver is always in the cab, so the cab design matters a lot. Not only that, this is really where I would say the Edison truck stands out way over the Tesla one. And what I'm going to say here, maybe it's offensive to engineers, but you can tell this truck was thought up and designed by a mechanic, not an engineer. That's not a rub against engineers. Obviously, engineers need to make stuff, but engineers are the type of people that think of inverted Torx bits. Mechanics are people that think, hey, let's make it simple, easy to work on so that either the owner or a mechanic can fix it quicker and easier with cheaper parts. And he's really going to show that in here, which it blows my mind how simple they designed this truck, but it also looks really great.
It's a prototype. One thing I do want to show off here is this door hinge. Just a nice mechanical linkage, no cable, easy to work on, easy to service. Let me show you some things in the cab that I think are really cool. Under here, the air lines come up here where they are super easy to service and work on. Like, if you need access to them, they're right there. They're not tucked in behind a firewall. Old school trailer jerry bar. You know how much this is? Like $80-100. It's metal, it's made to last. Another detail on this truck. Everything we use here is steel braided airlines everywhere. This stuff doesn't wear, it lasts forever. It's not gonna have the leaks that push connectors use. This is gonna last a very long time. This one, even if this thing does leak, it's metal. You can undo the screws, replace an O-ring if the O-ring's leaking. Same as the turn signal. Old school style turn signal. Kenworth had it all the way through the 60s, 70s, 80s, 90s. Western Star had it to the mid-2010s. Simple switches, easy to get, easy to work on, easy to replace. Simple air gauges, backlit gauges. Don't mind the fit and finish.
So let's stop it there. So look at how simple that design is. Also, it's a mid-seat. It's so you could, theoretically, you could have 3 people in there. I'm not sure how much room's on the left side there. But look at that. Most dashes are huge. They're plastic. And there's 5 billion wires and modules behind them. A lot of the brake system components and airlines are push lock plastic ones. So they're going to leak over time. You're going to have 100 little air leaks you'll never be able to figure out. But not only that, they're very difficult to get to. The treadle valve, which is your brake pedal basically, is usually underneath the cab. And usually the frame and the transmission and maybe a hornet's nest is tucked under them, so you can't really get to them when one of the 500 airlines is going to leak. None of that on this. Look at that. They have brass fittings coming right through the floorboard, very easy to get to. Obviously, this is a prototype production design, so, they probably tuck the airlines a little closer to the dash or something like that. But notice they don't have all that junk stuffed up into the dash. They don't have very expensive components that are hard to find or are very, we'll just say, expensive because they're very manufacturer specific.
About our truck is that this thing that looks like a headache rack is actually not a headache rack. Electric trucks need what you call a power distribution unit. We put ours in the headache rack, turned what looked like a headache rack so that it looks clean. It looks like it should be a truck. Because I'm tired of ugly looking EVs. It should just look like a thing. Now in an actual truck, if you needed to use it for a headache rack, we could relocate it into those side boxes in there, the power inverters, but for now, I want to be able to show it off because this is kind of what's cool. This side here is all of your contactors, your fuses, the safety equipment. This is what makes sure that the electric thing is safe. If there's an issue, it blows out fuses, shuts itself down. This is the ground.
So we're going to stop it right there. So yeah, you can see the headache rack here. It has pretty much all the electrical system to it. Not only that, it's very easy to access. You saw a couple huge fuses in there. Breakers would be better, obviously, than a fuse. If you're in the middle of nowhere and you blow a main fuse, you're probably not going to have an extra 600 amp fuse sitting around. But if you did have a resettable breaker, I'm sure they could design this. Remember that, folks, this is a prototype, but this is the one they built. So the headache rack design is pretty cool. It's very easy to get to, and vertical like that too. You're not going to be getting a lot of moisture and stuff, sprayed on it if it were under the cab or something. Very easy to get to, especially some of this is very high voltage, so you wouldn't want that in any hard to access area.
Ground fault monitoring all in this box. The middle cabinet here is all of your power inverters. These are what take the power from that generator and put it into the batteries that are under our feet right now. These are the inverters that take the power from the batteries and put it to the electric motor. Basically, you have AC power coming off the generator. Batteries store it in DC power, and then you got to take the DC power from the batteries back to the AC electric motor. So we just had to change how the power is from alternating a direct current between different parts of the truck. These are the inverters that do that. These are Danfoss DC to DC. They just take DC current and transfer it to other DC current. Really, there's a lot of extra space. We had an extra space in the headache rack. We probably could have put chains in and relocate, well, whatever.
So yeah, that's when you start getting into the real technical electrical stuff. Like he was saying, there's a lot going on with DC and AC current here. Obviously, the engine is going to have a 12 or 24 volt alternator that will produce DC that's needed for the lights, basically the truck chassis type stuff. But you also are going to have your motors, and I'm not talking about the engine, I'm talking about the motors that drive the axles, and those are AC. Now, one thing I was wondering is, he said there's a DC to AC converter, which I was wondering why you would want to do that, but batteries are always storing voltage DC because it's a chemical energy. The batteries can't produce AC. Now, the motors, I was wondering why they didn't use DC motors because, and I ended up looking it up and doing some more research, AC motors are a lot more efficient, and also motors like to get AC opposed to DC. It's very hard to run a motor without brushes with DC, so that's why they have a DC to AC inverter or converter there. And yeah, they've got a lot going on there. So that's kind of out of my league when you start talking about all the intricacies of the voltage and the DC AC converters, but they know what they're doing.
They're there. So that DC to DC, you got to remember that there's other things being run off of this truck. There's electric power steering, we have electric air compressor. We also have low voltage batteries to run taillights, turn signals, LED displays. So what it does is it takes the high voltage power from the batteries and it puts it into the lead acid batteries in these boxes on each side. And what we also have here is a plug-in. So you can pull up to a charger, plug your truck in, you're done at the end of the day, plug it in, done. Under here, you notice these are where we put.
So that's a really cool feature. It's a plug-in hybrid basically. So yeah, if you didn't want to run your generator engine as much, you could plug it in to charge your batteries and reduce the amount of times that you're going to have to be running your engine.
But our batteries, these are what make this hybrid system so efficient. So people ask, you still have a generator under there, what's the point of doing the batteries? It's because these are 4C rated batteries. What a 4C battery means is that it can discharge 4 times its capacity. So we have 280 kilowatt hours of batteries, so we can actually pump out 1,200 kilowatts, 1,500 horsepower. Of course, we're only using about 700, 800 horsepower on the back, but these act for your peak load demand. So when you're accelerating off the line, you can run a 350 horsepower diesel. It just maintains that average load on the batteries. When you need to accelerate, they discharge at that 4C, give you a ton of power, and when you're coming downhill, or you're coming down and you're slowing down to a stop sign, you take the power, put it back into the batteries.
So that's a really cool feature that, of course, diesel-powered trucks by themselves don't have. That's regenerative braking. Think about the amount of energy that a truck coming down a hill is capable of producing. You're usually using your Jake brakes or your service brakes to slow the truck down. You're wasting that energy. Jakes actually slow the powertrain down. Your service brakes are slowing it down. That much energy, what he's saying, could be put, if you had a way to harness that, back into a set of batteries, which is what you're doing. Think about a logging truck, for instance, which is what Chase's background here was. You are usually going uphill unloaded. So it's easier to go uphill unloaded, obviously. But what happens at the top of the hill, you're going to get loaded up with logs, and then you're going to have to come back down the hill. Now, normally, while it doesn't use a lot of fuel to move downhill, all that energy is being wasted. In this, you could be actually not only just not wasting the energy, saving it for the road, for going to the mill or coming back up the hill if you're unloading at the bottom of the hill. So very, very, very ingenious idea here. So this is the pickup truck conversion. It's a shorter video.
Built the world's first diesel electric semi-truck, and you guys have been asking, when can I get a pickup version? Well, I'm pleased to announce that we're going to be doing a pickup version done the same way as our semi-truck, available for a pickup. We've had a lot of success with our design ethos on the semi-truck retrofits, where you can take your old semi-truck, change it up, retrofit it into electric. We want to bring that same level of ethos. No planned obsolescence, right to repair, easy to work on, easy to operate, into a pickup. So if you got a classic old square...
So I'm going to pause it right there. Not only that, very nice choice of hat there, Chase, but you can see the engine there. He's running cat filters too, folks. You know, you got to like that. But one thing what did he just say? No planned obsolescence, easy to work on, easy to get parts for. He's not trying to make this complicated. You don't need an electrical engineering degree to work on his truck here. Maybe to design it, but that's what I've noticed in there. Like I said before, this seems like a truck designed by a mechanic, not designed by an engineering team or a design team. This makes a lot of sense. Not only that, the design here is going to be more efficient than just a straight diesel engine powered truck itself. So you're getting a easier to work on, easier to maintain truck that you yourself can fix a lot of the problems with, and it's going to be more efficient. I love this truck. I don't see any problems with this. I'm sure there's stuff that'll come up that, you know, maybe there's a weak spot here or there, but as far as design goes, it's like they took everything, laid it out, thought how they could produce the most intelligent design truck, and that's what they put into this truck here. But this is actually talking about the pickup truck, so let's get back to that.
Square body Chevy, an old OBS Ford, tired of the fuel mileage, you want to keep it on the road a few more years, we'll take this same thing we've done with the semi-trucks, bringing it into the pickup world. The idea is to keep these old pickup trucks on the road as long as possible. Get more power while burning less fuel. So you got a diesel generator running at 1 constant RPM. The batteries here provide peak load demand. The electric axles back here provide an insane amount of torque. Here's how a retrofit kit works. We remove the old axles and we put in the Edison E-axles. We drop the driveline and transmission and put a generator on it. Then we put batteries, an inverter, and control unit. In the semi-truck, we put it in a headache rack. In the pickup truck, I want to put it into an easy drop-in toolbox into the bed of the truck. We're already doing semi-trucks, so here's the plan on how we're going to integrate pickup trucks. We want to set up a dealership service network where we can make an easy-to-install kit that we can send off to certified Edison installers that can install it in your pickup. We're going to focus on building the semi-trucks, we're going to develop a pickup truck kit, and then we're going to work with a series of certified Edison Motors installers. We can ship the kit to them, you bring your pickup truck to a certified Edison installer, they install it for you, drive away, done.
So that's a really smart idea. So they're not saying, and this is not a huge company, folks. Edison isn't $50 billion. It's not Tesla. They are not trying to make their own dealership network. That would take, I don't even know how you would do that without billions and billions of dollars. What they're doing is, mostly independent shops is what it seems like, are signing up for this. So you already have an independent truck shop, bus shop, whatever. You can sign up with them, and what they're doing is you're not going to own their building. What they're doing is, hey, would you like to in the future be able to do these retrofits? So that's a really intelligent way of doing it. You don't actually have to build the network there. You're actually using a network that already exists. You're just tying in with it. Very smart idea. Now the pickup truck design, they don't have a prototype of that yet. What they're doing is they just came up with the idea. So I wonder on the cost of that, is how prohibitive that could be. And a lot of the stuff there, I'm wondering, what engine are they going to use? The engine alone, think if you have a 78 Ford four-door pickup truck. It's going to be very expensive to do this retrofit because you're going to have to pull out the engine, the transmission, the drive shaft, and the rear axle. If it's a two-wheel drive, or if it's a four-wheel drive, you're going to have to do front and rear axle. The electronics, you're going to have to then pay for a new engine, generator set, battery setup, the inverters, and the axle or axles. And that, like I said, that's not going to be cheap. I don't know what engine they're going to be using either. I highly doubt they'd be using a C9. A C9 is a fairly large diesel engine for a pickup truck. Maybe they're looking at something like a 3126 or a C7 or some other, maybe not even a Cat engine, because Cat didn't make anything smaller than the C7. I might be saying, oh, there's a Cat C4.4, the C6.6. Well, those are Perkins engines. They're not Cat engines. So I don't know. Obviously, they haven't built these yet, but they're in the design process. So I'd really like to hear more. And obviously, go to their page, folks. They have videos coming out all the time talking about this. So there you go, folks. We talked about Topsy, which is an amazing truck. I love that truck. We talked about their idea of doing pickup truck conversions. That's still more on the drawing board for them, from what I can tell. Very interested to find out what they end up going with engine options on that, what the cost would be. Old Dave, my pickup, he won't be getting that conversion, but it's good to know that that is a really cool idea out there. And we're talking about some of the specifications here. A lot of people wanted apparently to hear my ideas or my thoughts on it. Very cool. Topsy is so cool. It'd be so cool to see those trucks actually in production, especially if you end up getting a Cat engine. You'd basically be having like Cat new trucks with Cat engines in them on the road again. I'm interested to see what will end up happening with that production, if they'll be able to do that in the US with a Cat diesel engine, or what they'll have to go with a power plant with that. But very, very, very cool. I wanted to thank them. Also, they sent me some pictures that I could use for this video and for the thumbnail. So thank you to Edison over there, Edison Motors, and thanks for watching.